Okay, so here's the question. Find the critical points and extreme values of f of x equals absolute value of x minus 2 on 0 to 3. So our first step is going to be to find the derivative. And to find the derivative of an absolute value function, well, we have to turn it into a piecewise function. And so remember that this guy, absolute value of x minus 2, we have to split it up into two parts. One is the positive part, which is just x minus 2. And the other one is the negative part, where it's going to be negative of this guy. So negative x minus 2, or 2 minus x. Okay, now for this guy, this part, this is true when x minus 2 is greater than 0, which means that whenever x is greater than 2, that's when we're going to use x minus 2, because basically the inside is going to be positive, and then you don't have to worry about it being negative at all. So you can get rid of the absolute value. So it's x minus 2 when x is greater than 2. And then we use 2 minus x when basically the opposite of this one, so that would be when x is less than 2. Because if x is less than 2, then that means that the inside of the absolute value is going to be negative. So you find the negative of it and makes it positive. So notice that if you plug in a number that's less than 2 into here, it would be exactly the same thing as if you plugged in a number less than 2 into here. Okay, now to find the derivative, of this guy, let's write it down right here, is also going to be a piecewise function. Oh, and actually I forgot. When x is equal to 2, in this case it doesn't matter which one, so we'll just put it here, because notice that they're both equal when x is equal to 2. Okay, now the derivative is also a piecewise function. And then you just get the derivative of each one. So the derivative of this guy is 1 when x is greater than 2. And the derivative of this part is negative 1 when x is less than 2. Now, notice I didn't write the equal sign right here. That's because, remember, the derivative is a limit, and that means that it has to equal coming from the right side and the left side. But this guy, if you get the derivative coming from the right, it equals to positive 1. If you get it from the left, it equals to negative 1 at 2. So the derivative is actually discontinuous. So it's not defined at x equals 2. So, well, that right there gives us our first critical point. Because remember that the critical points are all the values where the derivative is either 0 or does not exist. So x equals 2 is our critical point. Now, where does the derivative equal to 0? There isn't any place, because it either equals to 1 or negative 1. So our only critical point is 2. Okay. So then, remember, since we're looking for the absolute maximum and minimum, what we're going to do is we're going to plug a couple things. The critical point, or points, and the endpoints also. Those are going to get plugged into the original function. Remember, the goal is that we're looking for which one's the absolute largest or absolute smallest. So in other words, we're going to compare the y values of all of these guys. So that's why we plug in these three into the original function. Then we're going to compare the y values. Okay, so for this first one, I get an absolute value of 2 minus 2, which is 0. If I plug in 0, I get absolute value of 0 minus 2, which is equal to absolute value of negative 2, which is just 2. And if I plug in 3, I get absolute value of 3 minus 2, which is just equal to 1. Okay, and then we pick them. So the absolute minimum would be this guy because that's the smallest one. You guys like my asparagus color? Absolute minimum occurs at the point x equals 2, y equals 0. And then the absolute maximum would be this guy right here when x equals 0 and y equals 2. And that's it. So we found the absolute minimum and the absolute maximum.